I think we should start now. Huh? People have not joined. Many people have not joined. 3, 1, 2, 3. Only 9 students are there. Total, how many students are there, Ruchika?
In MSc, there are 12.
12 and... oh, sorry, I forgot to inform those students, my MSc students. Just a second. Now, can you drop the message in MSc class? Sorry, your PhD group?
Yes, sir. Okay, sir.
So let me put. Okay, I'll share that. I'm starting recording and starting because it's already 10:12.
Recording in progress.
So, however, I have all Nidhi Abdul Baha. Okay, Abdul Baha is okay. Nidhi, switch on your. Acha, so, Nidhi has some problem. Okay, no problem. Membership function. I have just started last time. If you remember the membership function, by membership function, actually you are giving the fuzziness to quantity. Any quantity which has a single value. Any quantity which has a fixed value is called the crisp quantity. But any value which has some membership, means x mu x, then this is a fuzzy quantity. And this is its membership value, that how much probable that this value can take this x equal to suppose 0.9, how much probable it is, right? So that is the membership value. To represent the membership value for the crisp value, the membership functions are defined, right? The fuzziness in a fuzzy set is categorized by the membership functions. It classifies the element in the set whether it is discrete or continuous. There are two types of membership functions are there: discrete and continuous. And the very famous representation of membership function is the graphical representation. So let us start this. I already told you, but just for the completeness, I'm just quickly revising this. There are 3 major features of or properties of the membership function. Those are the core, support, and boundary. You can see that suppose this is your membership function. Suppose this is your membership function where it is your 1, suppose. So this part is known as the core, means core whose membership value is 1. This membership value is 1. This is also called highest membership value, is also called the height of the membership function. It is also called the height of the membership function. Maximum value. Height means the maximum value, right? So core whose membership value is 1. The set of all the elements which have the membership function as 1, membership value as 1, are the elements of the core. So core is the set of those x's whose membership value is 1. So you can define like core equal to x such that mu x is equal to 1. I hope it is clear. Core is clear. Then the question comes to the support. Support is this. Support is this, means whose membership value is greater than 0. Anything which is greater than 0 means all the x's whose membership value is greater than 0, and here from here onwards you see the membership value is 0. Here the membership value is 0, and therefore these x's, these x's are not the part of the support. Means you can define the support equal to those x's whose membership is greater than 0. And zero part is not the support. So this is not support. All these x's are part of support. Now the last definition is this boundary. Look, boundary is those part of the support. In short, it is those x's of the support whose value is not 1, is greater than 0 but not 1. Vantash?
Yes, sir.
So this x is mu x is greater than 0 but mu x is not equal to 1. In other words, you can say that it is x whose mu x is less than 1 and greater than 0. Is it okay? So boundary. Yeah, this is greater than 0 and less than 1, right? I hope these three definitions are clear. Based on this, just all these definitions must be crystal clear after this. Prabhat?
I'm not getting the definition of support through the diagram.
This is support? Prabhat, can you call other PhD students also? Actually, I forgot to inform you people. I will include you also in this group of soft computing so that whenever I take the class, you should be aware. Next time I'll add. Right now you try to contact other boys. Okay, what I was saying, Ruchika, look, suppose this is one value, right? And this is your membership. Suppose this is only the membership, right? This is only. So here you see the only value is this, x has only this value. Suppose x extra. So in this core is only x extra, right? Now the support has, suppose this is your x0 and this is your xn. Then the support will be, all, let me call it like, is it okay? It is like this. This is your support. All the values from x0 to xn, right? Whose value is non-zero. This is non-zero. Excuse me. This is non-zero, right?
We are
And
defining membership value through y-axis.
y-axis means this is the membership. Oh, were you absent last time?
No, sir.
Look, this is x and this is your mu x. So this mu x is non-zero. This is some value. So these mu x's are non-zero and therefore these x0 to xn are the part of support. While in the boundary will be x0 to xn minus x extra, because it is less than 1 and greater than or equal to and greater than 0. That is your boundary. So for this membership function, this is core, this is support, and this is boundary. Okay, Ruchika?
Sir, got it. Yes, sir.
सीतू मैम ब्रेकफास्ट कर रही है, यहाँ रही है अभी.
ठीक है. और क्या नाम उसका? प्रतु सो रहा होगा ना प्रतु तो. प्रदीप, म्यूट योरसेल्फ. देयर इज डिस्टरबेंस फ्रॉम योर साइड. ये लड़के ना रात भर तो जागते हैं फिर सवेरे सोते हैं. सुरेश ऐसा नहीं करता है. सुरेश हंस रहा है. ये ऑनलाइन टीचिंग ने ना सबका शेड्यूल गड़बड़ा दिया है, इसीलिए जल्दी ऑफलाइन हो जाए. हम लोग शिफ्ट कर रहे हैं.
Will you be taking offline from 2nd March?
हो ही नहीं सकता ना सेकंड. मैं तो लेना चाहता हूँ. मेरा मन तो आज से लेने का है, बिकॉज दिस इज ए बिगेस्ट चैलेंज फॉर मी. और शायद इस डिपार्टमेंट में, यूनिवर्सिटी में मैं हूँ जिसने शुरू किया कि वीडियो ऑन करना कंपलसरी है. अपने मीटिंग में मैंने बोल दिया, मैंने तो ऐसे किया. अब सारे लोग बोलते हैं हाँ ये सही है. और शुरू में पहली बार में तो स्टूडेंट्स बड़े रिलेक्टेंट थे वीडियो ऑन करने के लिए, क्योंकि वॉल को पढ़ाना इज नेक्स्ट टू इम्पॉसिबल. मतलब मैं पढ़ा रहा हूँ, मुझे पता ही नहीं है कि मैं किसको पढ़ा रहा हूँ, कंप्यूटर की स्क्रीन से बोलता चला जा रहा हूँ। तो ऑफलाइन टीचिंग इज ऑलवेज बेनिफिशियल, इज ऑलवेज बेटर, है ना, इज ऑलवेज मोर इफेक्टिव। तो मेरा तो मन है कि आज से चालू हो जाए, लेकिन हो नहीं सकता। ये गुलाम वहां बैठा है, अब्दुल वहाब फिरोजी वहां बैठा है, कैसे होगा? और हमारे पास इतने कैमरे और इतना आईटी अरेंजमेंट नहीं है कि हम लाइव क्लासेस को, मतलब क्लासेस को लाइव कर सकें, सारी क्लासेस को वहां पर। जैसे उन्होंने बोल दिया हाइब्रिड में बोलने को, तो क्या कोई भी नोटिस निकाल दो, है अरेंजमेंट्स, है ना। तो वो कुछ नहीं है, ऐसा वैसे ही चलेगा। अब जब तक हम लोग शिफ्ट नहीं हो जाते वहां पे, तब तक ऐसे ही चलेगा। हो ही नहीं सकता, सवाल ही नहीं है, प्रैक्टिकल नहीं है ना वो नोटिस। तो ऑफलाइन नहीं होगा। ऑफलाइन क्लासेस केवल तब हो सकती हैं जब हमारे पास वो जो ट्राइपॉड और कैमरा और वो जो सारा ऑडियो वीडियो सिस्टम जो होता है ना, पीछे क्लास के लगा के उसको प्रोजेक्ट करके और उसकी लाइव स्ट्रीमिंग लोगों को दिखा सकें जो ऑफलाइन है, सॉरी जो ऑन साइट नहीं है, और वो उसकी लाइव स्ट्रीमिंग भी इतनी फास्ट हो। मेरे बच्चों के स्कूल में होता है ना, एक्चुअली बच्चों के स्कूल में है, तो वो अच्छा है उनका, उनके पास है इतने अरेंजमेंट्स। अभी हम लोग इतने अरेंजमेंट्स कर पाएंगे वहां पर? इतने कैमरे, इतने आईटी पर्सन ही नहीं है कि लगातार, मान लो 10 क्लास अगर लगातार चल रही है, तो हाउ विल मैनेज दोस 10 क्लासेस? Definitely all the Afghan students are there. No Afghan student is on the campus. New Afghan students. How they will attend the classes otherwise? So this is the biggest challenge, and hope to get problem resolved by the June for the Afghani students also, so that they can also come on site and can attend the classes. I don't know what will happen, but right now the offline classes may not be possible. Practical, not practical, it will create even the disaster. Okay, so the crossover points. Okay, I defined you the core boundary and support, and then one is the crossover point whose membership value is 0.5 is called the crossover point. Height I already defined is the maximum of this. Means height of the membership function. Suppose this is your membership function, then this height is the maximum of, is the max of mu x, is the maximum height. You know, it is not necessary that it is always 1. Suppose this is 1 and your membership function may be this. So suppose this is 0.4. In this case, the height is 0.4. Dorji, is it okay?
Yes, sir.
The classification of fuzzy sets: normal fuzzy set, subnormal fuzzy set. So normal fuzzy sets are those which has at least one element in the universe whose value is 1, whose membership value is 1. Means there exists x in the fuzzy set such that mu x, right, is equal to 1, then it is called a normal fuzzy set. Subnormal fuzzy set, if the membership function has the membership value less than 1, then this is called the subnormal fuzzy set, right? So the means, in other words, you may say that the height, if the height is 1, then it is normal. If height is less than 1, then it is subnormal. Pradeep, is it okay? If the height of a fuzzy set, if the height of the membership function of a fuzzy set is less than 1, then it is subnormal, and if it is equal, then it is normal. Convex, if the membership function has membership values, those are monotonically increasing or monotonically decreasing, or they are monotonically increasing and decreasing with the increasing values for the elements in the universe, then fuzzy set A is called the convex. Last time I discussed a lot about this. Let me again tell you So let us wait for just 1 minute.
Recording stopped. Recording in progress.
So the convex, look, the set is said to be the convex set. I was talking here. If the membership value is increasing in the membership function, the convexity of the fuzzy set is decided by its membership function, right? So if the membership value is increasing and then decreasing, or decreasing and then increasing, it's okay, convex. But if it is increasing, decreasing, and then increasing and decreasing for the set of universe, this is your universe set, right? So in this case, it is a non-convex set, it is a convex set. The intersection of two convex set is also the convex set. I hope it is okay. It is making sense. You already know this. The intersection of convex set is the convex set. Now the fudgification. This is the one which today we are going to study, all the fudgification methods. Fudgification is an important concept in the fuzzy log theory. So the fudgification and then defudgification. Look, I tell you that what is this fudgification means. What is this? Look, there is some controller or something. You may say some processing unit is here. This is some processing unit like thing you understand, right? And then you have some crisp quantity which is to be dealt with the fuzzy controller or some processing unit using the fuzzy concept, right? Then you need to convert this. Then you need to convert this using the fudgification. So the crisp quantity will be fudgified, and then whatever is the process is to be done. And this is called the fuzzy inference system actually. So this I'm going to tell you, hold on. And then after having the fuzzy inference system, for this fudgified value, you will do the defudgification. And then you will have again the crisp value. After the defudgification, you will have again the crisp value. So crisp to crisp you will get, and within this, all these steps are there. So you realize that there are major 3 steps. One is the fudgification, another is the defudgification, and in between there is a fuzzy inference system who is doing something with that fuzzy quantity. Let me again tell you that you have a crisp quantity. You have a crisp quantity, and this crisp quantity is fudgified, and then it went to the fuzzy inference system. Fuzzy inference system do something. What it is doing, I'll tell you, right? It is making certain rules for that, over this fuzzy quantity, that okay, for this input the output will be around this, right? Around this, will not give the exact output. So what it is doing, this is our not the matter of today. And then it will be, since the output of FIS is also a fuzzy quantity, you will get a fuzzy quantity. You will get a fuzzy quantity, right? Fuzzy decision. You may call it fuzzy decision. From the fuzzy inference system, you will get a fuzzy decision. You have a crisp rule, or crisp input, you made it fudgified input, enter to the FIS. FIS output is a fudgified decision, is a fuzzy decision. Now to understand by the human beings to some system for useful rule, you need to do this defudgification. You did the defudgification and you will get the crisp quantity or crisp decision, whatever is the crisp decision, fixed decision, right? So fudgification, defudgification, and FIS, these are the three major components. And once we will do this, we are done with the fuzzy systems, fuzzy logic. What I tell, three things are there: fudgification. Three things are there. Listen again carefully. This is our ultimate target. Now actually, after having the basic knowledge of the terminology, now we are moving towards the implementation part. So fudgification is the one thing, then FIS, and then at last there will be a defudgification. So you are admitting? Okay, so three things we are going to study. Let us start with the fudgification. I hope now you understand actually what we are going to study. Till now, I have given you only the basic terminology about the fuzzy logic, fuzzy set, fuzzy systems, right? Now I'm telling you the entire process, and this process will be done with the help of MATLAB toolbox also. At last, I will give you the MATLAB toolbox hands-on also in this, right? How actual problem I will solve you. Actual problem, the temperature problem or whatever I'm giving you, the gear system problem, will solve you with the help of MATLAB toolbox, right? But before that, let us understand theoretically. Clear, Gulam? So the fudgification,
Yes,
we are going to do the fudgification of the crisp quantity. Whatever the human's input will always be the some linguistic variables. Our input will always be linguistic variables, right? So we will do this. We will do the fudgification of the input. So fudgification is the simple conversion of crisp to fuzzy value. Crisp to fuzzy. Crisp to fuzzy is called the fudgification. Very simple language, right? So the fudgification is the process where the crisp quantities are converted to fuzzy quantities. Crisp to fuzzy. Simple, one line rule. Fudgification means crisp to fuzzy. By identifying some of the uncertainties present in the crisp value, we can convert this to the fuzzy value. The conversion of fuzzy value is represented by the membership function. The membership function that I told you is the major representation for the fuzzy value when we convert the crisp value to the fuzzy value. Okay, so these are the practical applications. As such, these are, I have already explained you the applications in industry, measurement of voltage, current, temperature. It is negligible error, but that error is there. So to consider that error, we need to convert this fudgification process. Now the fudgification is done. The fudgification process may involve assigning membership values. Look, suppose you have a input. Suppose the temperature is 30 degrees. I asked Pradeep that what is the convenient temperature for you, right? Comfortable temperature or pleasant temperature for you. So he said that 30 degrees. So this is the crisp input. Now we have to convert this crisp input to the fuzzy input to the system, so that system should not take only the 30 degree as the pleasant weather. It can take 29, 28 also, and 31, 32 also, right? And therefore, based on this crisp input is to be converted to the fuzzy value. This crisp value is to be converted to the fuzzy value. How we can convert? What we can do? We need to represent this. Suppose this is your temperature crisp input. We can convert this to the fuzzy based on our own, based on common sense. Based on common sense, I'm telling you that the membership function for this crisp input may be like this, that this is your 25 and this is your 35 and this is your 30 degree. So the membership value of 30 is 1. Means at 30, he will feel the maximum comfort, right? So the membership value is this, and the membership value of 29, 20, up to 25, it is keep on decreasing. And here up to 35, it is keep on decreasing. Suresh, I think it is making sense. This process by which you understood just a common sense. Pradeep said that 30 degrees is my pleasant temperature. So based on your common sense, what you will say that he will also feel comfortable at 25 and he will also feel comfortable at 35, but less comfortable. But he will feel comfortable, but he will feel the maximum comfort at 30 degree temperature. And this is your membership function. This is called the triangular membership function. Triangular membership function has been created. Guntas, any doubt in this?
No, sir.
All clear, Harshit?
Yes, sir.
So this we are going to do. We are going in the fudgification. We are going to develop certain rules and regulations, Situ, by which we can convert these fuzzy quantities to such kind of membership functions. There are various methods to assign the membership values, and the assignment can be just done by intuition or by some algorithm or logical procedure. So this, of course, I have done this based on intuition. Suresh understood. Suppose the job is given to Suresh of that you design a temperature controller in the room of Pradeep. So he will say that, okay, minimum will go to 25 and maximum can go to 35. Because if he's saying 30, then he can accommodate 25 to 35, right? So Suresh has done this based on some his own intuition, based on his own understanding. And there may be larger problems. There may be problems where this intuition may not work better. There may be better methods. So of course, some logical procedures are there. I'm coming one by one. Right, look quickly. So today I will finish all these methods, right? Fudgification methods and then defudgification method, and FIS will be the last. No, look, this middle part, the last section, and then we are done. This is the only fuzzy logic. You know, the entire subject is finished. If you understand fudgification, defudgification, and fuzzy inference system. Let me tell you, if I'm covering all these, doesn't mean that I have finished everything about the fuzzy on the earth. Whatever is about the fuzzy on the earth, I have finished. You know, there are thousands of the methods for fudgification, thousands of the methods people have developed for defudgification, thousands of the methods of the most important is the FIS have been developed, right? So again, people have also developed many type of fuzzy set. This is not only the fuzzy set. People have developed different type of fuzzy sets also. You know, you will be wondering that there is another kind of fuzzy set that is called intuitionistic fuzzy sets, in which what happens, your membership value is again a fuzzy quantity. You have your value is the fuzzy quantity which has some membership value, and now membership value is again a fuzzy quantity. So type 2 fuzzy sets, we call them the type 2 fuzzy sets. So many types of fuzzy sets have been developed. Is it okay? Mohiddin, what's going on? Now you should come back to the campus. It's enough. बहुत हो गया. 2 months, more than 2 months, you are muted. Your work is suffered, I think. Your work is Mohiddin, you are muted. Intuition. So the intuition
Yes, sir, I am planning to come, sir.
Very good. Very good. So intuition is based on the human's own intelligence and understanding to develop the membership function. The thorough knowledge of the problem has been known about before you do the fudgification, and this is the one I already told you, right? Like if you are giving that this temperature is comfortable, then minus 0.5 and plus 0.5 is also comfortable, right? So suppose in the AC, you set that the 30-degree temperature. In the mobile, not 30, who said the 30 degree, 25 degrees and 25 degree temperature you set for your room. Will the AC will definitely be always will be able to maintain 25 degree exact? Is it possible? So this temperature which it is maintaining is fudgy quantity, and therefore when the learning when this knowledge or when this intelligence is trained to the AC, to that air conditioner, it is trained in this way that it can, this quantity is a fudgy quantity. When I'm in my remote, I'm entering 25 degree temperature, it means it's a fudgy quantity. It can go 24 also, it can go 26 also. If you check with the most what is called sensitive instruments, then even if you are setting 25 degree, the temperature may be 23 or maybe 26 or 25. I hope you understand. This is not possible that always you can maintain the crisp quantities. There are certain situations, and this is the one situation. So this intuition is this. Another example is this. Another is this example. I think Dhruv. Okay, this is related to the speed of a DC motor. So the speed is the temperature is the one thing, right? Now there may be many memberships, many range gauge. For the input variable speed, this speed is this. This side it is speed, and this is, if it is 500, or suppose it is here is 300. So up to 300 it is considered to be the low, and here also it is considered to be low up to, but the membership is decreasing. And from 500 the membership is increasing for the medium, and at 1000 it is this membership to be the medium, but simultaneously it is low also with this membership. You try to understand that 1000 is the low. 1000 at 1000 it is the probability or the membership that the speed is low is 0, while it is medium, this membership, and this is suppose 1200, then 1200 is medium, is not low. 1200 speed is not low, it is medium. Similarly, here this 1500 is within the medium also and in the high also, and after this it is always high. After this, suppose it is 2200 RPM, then it is always considered as high, and here suppose it is 300, then as less than 3 it is always considered as low. So these kind of membership functions are called the trapezoidal membership functions, and this is called the triangular membership function. Let me explain again what I'm telling you. There may be certain situations where you need to represent the fudgified value with many membership functions, and these membership functions need not to be the same. Okay, there may be same also. Remember, there may be same also. Means all are triangular functions. This situation may be also be there, and that situation may be this kind of where the trapezoidal, triangular, and trapezoidal may also be there. And the same logic I can give for the gear problem. You remember the gear problem? You remember the gear car, automatic car gear system? So suppose I'm giving the first gear. Suppose you have a 3-gear car only. Suppose you have 3-gear car only, right? 3-gear car, right? Usually in cars, either 5 gears are there or 6 gears are there, right? Just for example, I take a 3-gear car. So first gear, there is always, suppose here it is, instead of 500, let me write it 20, right? It is 20, and second gear, suppose it is 40, and suppose it is 50, and it is 60, right? Can you just consider this? So now you see here, this is around 17. So if 17 km/h speed is there, then the first gear will always work. But the probability of first gear will keep on decreasing up to this. Let me write it 30, right? And from 20 onwards, second gear chances will keep on increasing, and here it will always be second gear, and the second gear chances will keep on decreasing, and here onwards the third gear chances will keep on increasing, and after this speed always the third gear will work. This happens in the automatic gear system, that before certain speed it is always 1 gear, and after certain speed it is always 1 gear. Actually, in my car, I also have an automatic gear car. So in my car, sometimes the 6th gear started at 50, 55, and sometimes it never goes up to 70 also. It depends that how much accelerator quickly I'm taking, or I'm going on the highway and slowly the speed reaches at 60. So the car automatically understands, the sensor automatically understands that it is from longer distance he's coming. It's a highway, and let us take the 6th gear. But if suddenly I take the gear, so at 60, so there is a chance that I just want to cross something, and the gear will not go. The car will give the power, will not increase the gear, and the chances that it is medium also, means the car is still running in 4 or 5 gear also. Try to understand, this is required. This is required. Not always the 6th gear can help you, right? 5th gear and 4th gear also required at certain times. And therefore, there are certain common areas. These are the common areas where the second gear will also work, third gear will also work. So your membership function can be this type of also. And this is the first method, intuition method. But sometimes intuition method may not help you in large problems or some more complex problems where you may not understand all the things properly, right? Nidhi?
Yes, sir.
Very good. Nidhi promised me कि मैं बहुत ज़्यादा attentive रहूँगी, मुझे कुछ दिन के लिए वीडियो ऑफ करने दो. Actually इसको थोड़ा इंटरनेट का प्रॉब्लम है. Okay, but remember, you must be attentive, equally attentive. Seetu, why you switched off your video? Inference.
वो लैब में सफाई करने आई थी.
अच्छा ठीक है. Now the second method is the inference method. Inference method means based on certain rules, right? So this method involves the knowledge to perform the deductive reasoning. Based on some knowledge, you derive some reasoning, right? The membership function is formed from the facts known and knowledge. From whatever the facts we know about the problem and whatever the knowledge we have, facts and knowledge both will help you to determine this. Suppose, for example, this example is very good example. So let me explain this concept with the help of this example. Let U be the universal set of triangles, and A, B, and C be the inner angles of the triangles. And this is the condition that A is greater than or equal to B greater than or equal to C. Therefore, the universe is given by the triangles with angles ABC, where ABC has this relation, and A plus B plus C, of course, 180. No need to say about this, right? So this is your problem. That means the set. Now we need to identify, we need to classify these triangles into 3 categories. Remember, we need to, in this example, what we did, we have identified the gear system into the speed into 3 gear systems. That first gear, second gear, and third gear. The car will go to first, second, or third gear it is to be identified, right? Similarly, here we need to identify these triangles into three categories: isosceles triangles, right triangles, and other triangles. Why this word appropriate? Fuzzy quantity. Approximate or appropriate means fuzzy quantity. That's why I'm calling them, Gulam, I'm calling them appropriate or approximates. Okay?
Yes. Okay.
So for identifying, we define three types of triangles. Three types. You may define other, the speed of the DC motor. So low, medium, and high. You can define some other categories also. Very low, low, medium, very medium, small medium, high, very high, superlative high, whatever kind of variations or classification you want to do, you can do. For time being, we have done this kind of classification. Let us understand now, based on some rules, based on the knowledge about the isosceles triangles, that about there must be some conditionless triangles. Tarun, what is the definition of isosceles triangles?
Two sides are equal. Two sides are equal.
Two sides are equal, at least two sides are equal, or at least two angles are, inner angles are also equal. Is it okay? So not two sides, at least two. If three are equal, then also it's a isosceles triangle. Is it okay? No doubt. Let us start. The membership value can be inferred to all of these triangles types through the method of inference, as we know the knowledge about the geometry of the triangles. Based on this geometry knowledge, right, the facts about the geometry, this is the inference method. Based on that rules, that if the angle is, suppose if there is an angle close, okay, exactly 90, suppose exactly 90, then my knowledge about the geometry says that it is a right angle, angled triangle, right triangle, right? So what actually I want to say, based on these kind of rules, we can say that the membership value, if it is 85 degree, then the membership value is very close. But if it is 60 degree, each triangle, each angle is 60 degree, then the membership value of this triangle to be the right triangle is less, while the membership value of being the isosceles triangle is high. Is it okay or not, Prabhat? So it is not exactly 90 degree. Even if it is 85 degree, I will say that the membership value 0.9. How it is calculated? We can define some formula. So it's a quick, you can easily understand. These are the rules. Then the membership value of the isosceles triangle, this I for isosceles triangle, for this triangle, ABC is a one triangle. It is the isosceles triangle. The membership value for this you can define in this way. This is very simple formula. You can define some other formula also for other problem. For this, it is very simple. Look, A, B, C are 3. A is greater than or equal to B is greater than or equal to C. So you are calculating A minus B, B minus C. You told me that minimum two sides are equal. Minimum two sides are equal. It means what should happen? What should happen? This is your, suppose, angle, or two angles are equal. Suppose A, B, and C. Suppose these are the angles. Suppose these are the angles, then A minus B and B minus C. What I'm doing? These angles, difference I'm taking. So this should be 0 and this should be 0. If it is actually isosceles triangle, then these two should be 0, and then minimum of this 0 and 0 will be 0. And if this is the 0, then it will be 1. So the membership value of isosceles triangle, when it is actually isosceles triangle, is equal to 1. And if this is not 0, if this is not 0, then your membership value will be decreased. Based on this, it will be 1 minus this. And what can be the maximum? What can be the maximum? This difference, what it can be? This value can be 0. Membership value can be 0. Look, what actually I want to tell you. The membership of isosceles triangle is equal to the 1 minus 1 by 60 and the minima of A minus B and B minus C. Look carefully. This membership value can be 1 or can be 0 or in between. You agree or not? The membership value can be in between 0 and 1. So 1, I already told you that when both the angles are equal, then it will be 1. Correct. When it will be 0, tell me. Ruchika, you tell me when it will be 0. Means when you are sure that it is not isosceles triangle, that the triangle is not an isosceles triangle, then you are sure that it is. Then
When it
you are
is
sure that
at
when this
at
the
boundary.
minima is when this difference minima is 60. What are the options? What I can take the value of A, B, C, so the minima of this difference and this difference will become 60. What I can take? 30, 90 and 60. This is 60 and this is 30. What I can take?
Sir, one should be greater than 90, sir, on angle.
Oh, sorry. This is your 60 and this is your 9. Yeah, tell me. ये ठीक लिखा ना मैंने वैसे तो. This is your right triangle actually. Deliberately I am writing it.
Yes, sir. It is possible.
Or you can simply write 90. Actually, the condition is this. So just it is okay. It's a matter of just.
Yes,
So-
sir. Okay, sir.
So this difference is 30 and this difference is 30. So the minima is 30. In this case, the minima will be 30 and it will be 1 by 2. It will be 1 by 2 and the probability will, and this membership value will be 0.5. And can you just suggest me when I can write 60 and
A equal to 30, B equal to 90.
no,
Sir, I don't think it will be possible for any specific triangle because the only possible value so that the sum is 180 is 0, 60 and 120.
हाँ,
Yes.
so
No possible triangle.
no possible at 0. Yes, you are right. So 0 angle, one angle will be 0 only then one angle is 0 and 60, 20. 0, 60 and 120. Only then it can be 0. So yes, it is the case. In that case, it will be 0. Right? So it is close to 0. If you will put it, suppose 5 and remaining whatever the value, it will become closer to 0 and 1 to 0 it can decrease. Yes, all the values can achieve this from 1 to 0. So this is the membership function. Based on this rule, you can define the membership of this. Now you just take an example. Take an example where I'm coming to that right angle. I'm coming to, right? So just take this example, 35, 85 and 60, right? So this is your A, this is your B and this is your C, right? So the membership that this triangle membership value, this triangle is an isosceles triangle, is equal to 1 minus 1 by 60, and tell me A minus B is your how much? 25 comma B minus C is, tell me.
25.
25 again.
Sorry, 25. So it is 1 minus 20 by 60. So whatever is the value, can you tell me? कितना हुआ? जल्दी से, quick.
Took 0.6. 0.6 approximately.
It's okay. So approximately 0. Value of this to be the right triangle, right? It will be 1 minus 1 by 90 and a minus 90. Can I write like this? The same logic for the formula. This is the membership function for the right triangle. 1 minus 90, a minus 90. What is the condition for the right triangle? One angle should be 90 degree. One angle should be 90 degrees. So can I put this condition here? And in that case, let us calculate, for the same example, let us calculate the membership value of, since the one angle is 85 degree. So my common sense suggests me that the membership value of this right triangle should be higher than the isosceles triangle. Agree or not, Dorji? Dorji, you agree that since its one angle is 85 degree, which is closer to 90 degree, and therefore the probability that this triangle is right triangle is higher than the probability that this triangle is an isosceles triangle. Situ.
Yes.
So what I'm going to put 1 minus 1 upon 90, and whichever angle is close to this is 85 minus 90. So okay, forget this minus sign. You understand that we just want to take the difference, right? So this is your 5, and what is the value then? Can you tell me?
So 0.94.
Look, the membership value of this is much higher than the membership value of this to be isosceles triangle, because of course, and logically also correct. Prabhat, right? This is the way how inference means by some logic, some mathematics, some rules, you are defining the membership values instead of common sense. Means rules are defined to determine the rules are defined based on some inference, based on some rule, based on some method, some knowledge, based on facts about the criteria. Now for others, the third category, you remember the three categories were there? So the third category can be defined as the complement of this. I think this is okay. You understand this? The isosceles triangle, right triangle, all the triangles complement other than the isosceles and the right triangle. So that is other triangles. Or by De Morgan's law, you remember this De Morgan law? It will be this. It will be this. Actually, sorry, it is wrong. It is a mistake here. It is this, right? And intersection, you already know the intersection of two fuzzy sets, right? What is that? Minima. So, and complement also, you know, what is the complement of this? Is 1 minus this. Complement of this is 1 minus this. And intersection means the minima of this. We are done. The membership. Now let us calculate the membership of other function for the same example, 85, 60, 35, right? Okay. This is the minima of 1 minus. And what is this value? You remember? 0.6. And what is this value? 0.9. So this is the minima of, tell me, 0.4, 0.1, and this is your 0.1. It means the chances, the membership value that this is neither isosceles nor the right triangle is 0.1. The membership value that it is neither isosceles triangle or nor the right triangle is 0.1. Harshit, all okay?
Yes, sir.
This is clear or not? This inference method is clear or not? Inference method is not some rule, some steps or something. It is means you have some knowledge about the problem, and based on that you made some rules, and then you are creating the membership values instead of just common sense. And if it is based on just, then it is called the intuition method. These two methods are crystal clear, Bantash?
Yes, sir. Clear, sir.
So all these calculations are done here. It is 0.055. How you did it? Acha, ye, sorry. So, this is, they have taken the 3 places, correction. Correct values. The next method is the rank ordering method. Now, in the rank ordering, what we do? Actually, the membership values can also be defined based on the survey. Suppose I want to buy a new car. Ruchika, suppose I want to buy a new car.
Yes,
In
sir.
that case, instead of some rules, regulations, or based on some features or something, I do not know the features. Even if the salesperson is telling me the features, sir, this is this, this is this, this is this, I don't know features, right? In that case, what the other way I can do, right? That I will ask from Ruchika that which car you prefer. I have these, I will go to the market and based on my pocket, I will make the list of the cars that, okay, these cars I can buy in this much money, right? I will make the car and will go to the Ruchika and say that, okay, out of these cars, if these 2 cars are there, which car you would prefer? Go to Prabhat will give, okay, I will prefer this car. Gulam will prefer this car. Dorji will prefer this car. Actually, based on the ranking of the cars by the different individuals, without any knowing about the features, they were preferring because they are the users. They are the users of the cars. So they know in advance that over these 2 cars, I prefer this car. I do not know about all the cars, but if you give me car A and car B, I can prefer the car A. This kind of feedback, if we can take from the users, from the survey, then from that survey table, we can make the membership value. Let me tell you how. We can fudgify the values. Look how. Suppose there is this can be explained with the help of example, right? So let us take the example of this car. 1,000 people are there who are giving the response. There are 1,000 from 1,000 people I'm asking before buying the car that which car I should buy, to a questionnaire about the pairwise preference among 5 cars. 5 cars are there total: Palio, Sienna, Astra, Easter and Baleno. Right? अभी ये बहुत सारी पुरानी कार हो गई जब ये किताब लिखी होगी तब ये चलता होगा. पालियो आजकल कौन खरीदता है? कोई फ्री में दे तो ना खरीदे पालियो. Okay, so the 5 cars are there. Out of these 5 cars, which cars would be preferred? So for these 1,000 people, for the best car, we need to define the universe of cars, best cars, and these five about these 5 people, 1,000 people gave the response. So look how they gave the response. Out of 1,000 people, listen carefully about this table. Number who preferred Palio over Palio. Of course, no, this comparison is not possible, right? So dash is there. Now Sienna is preferred over Palio by 481 people. Out of 1,000 people, 481 people preferred Sienna over Palio. Sienna is preferred not over Sienna. Sienna is preferred over Astra by 475 people. Sienna is preferred over Easter by 845 people. Sienna is preferred over Baleno by 580 people. Palio is preferred over Sienna by 515 people. Palio, what is called Palio is preferred over Astra by 545 people, and so on, right? So this Sienna is preferred over other cars. Total is this 2-3, means out of 1,000 people, when we compared we asked that Sienna over other cars, pair-wise comparison, then this much time. Remember, total will be, tell me how 5 cars are there and 1,000 people are there. So total how many, and pair-wise comparison is there. So total observations will be 10,000. I hope simple logic, right? Out of 10,000, actually 2,381 people are 2,381 times Sienna is preferred. Palio is preferred over 2,254 times. 2,254 times Palio is preferred. 2114 times this Easter is preferred. Baleno is preferred 1481 times. From here you can understand that the membership value of Palio, the Siena is highest. So the rank is 1 for this. Astra, sorry, this rank is 2. This Palio rank is 2, and so on. You understand? These cars are given the rank. Now it means out of 1000 people choice, I should go with the Siena car. I will should go with the Siena car. So this is the rank ordering that we have done, and based on the preferences, the percentage is calculated, the ordering is then performed, and its membership value, it's a discrete membership function. So its membership function is defined like this. Look, suppose this is your X. X means car. Palio, Siena, Astra, Easter, right? So it's ranking or this percentage. You can mark anything. Ranking or percentage, whatever you want to mark. So suppose the ranking percentage I'm marking. So this is 22, this is 23, this is 17, this is 21, and this is 14. This is the membership function of by rank ordering method. Prabhat, any doubt? This is a discrete membership function because you cannot buy the car. Temperature is a continuous quantity, but car is not a continuous quantity. You can buy either Astra or Siena. You cannot buy Astra plus Siena is divided by 2. So you understand what does it mean? It is not in this example the speed, temperature, those things were the continuous variables. So you can take in between something. Here the car is a car. So you cannot go in between the car. There is no car between the Siena and Astra. Can you define any car which is like this? Can you define this car? Will it be a car? So of course your membership function will be a discrete membership function. So this is your membership function, discrete membership function. So Siena is on top, right? This angular you can leave. You can leave the angular neural networks. I'm telling you, and genetic algorithms will also I will left. So neural networks. Let me tell you. Since I already taught you the neural network, so you can immediately understand the membership functions made with the help of neural networks. Listen carefully. So look, suppose there is one input which has 2 variables, x1 and x2. There are total 14 data points. Total 14 data points whose values means one data point is this. This is your one data point, right? X2 is your, suppose y1, y2, and so on. So these kind of 14 data points are there, and each data point has 2 values, some points, and these points are in some x1 and x2 axis. So these points are here, like these points are there. They are 14 points. 14 points are there in this space like this. Now we want to find out that which point belongs to which region. There are 3 regions classified here. 3 regions classified here. They are the other 3 regions, and we want to find out that what is the membership value of which point to the R3. This is suppose R1, R2, and this is suppose R3. So in these regions, what are the minimum value, membership value? Suppose this point is here. Suppose this is your X1. Then, of course, the membership value of X1 for the R1. Membership value of X1 in the region R1 is 1, while the membership value of X1 for the region R2 is 0, and the membership value of R3 for the X1 is 0. You agree or not? Because it is already, we know that it is in region 1. So the membership, this is a classification problem, simple classification problem. You know this. I'll give you some. Look here. Look, this is, it is typed. I just, you know, look, it is, this computing, it is recognized correctly, while this word is not recognized correctly. This word was not recognized correctly. This is classification. Based on the classification this computer is doing, there is a program inside it that it is, you know, identifying my handwriting. Now look, very softly I will write. Now it is recognized. And if, you know, roughly I will write, then, oh, this time it is recognized. Sometime it may not recognize. Now it is recognizing every time. Okay. Now it is not recognized. You have recognized that sir has written the computing, but it has not recognized. It's a classification problem, that which letter is close to which. If I write like, you know, I actually made the right sign and he's considering it as he's considering it as V. You understand that it is a classification problem. Very simple. You immediately seen the application of this classification problem. So it is a classification problem. So there are the points x1, this is x1 axis, this is your x2, and the regions are three regions are there. Which point belongs to which? This point is belongs to in no region, and therefore, but it is very close to R2. So the membership of this point will be very close for R2 will be means very high. It will be not be 1, but it will be very high in that case. So in the neural networks, what happens? Neural network based designing of the membership function. What happens? You have these three regions, and this data is inserted to the neural network. You know, neural network, you train the system based on the input. So this, suppose this there, this is the first point, 7.8, and 7.8 is inserted and saying that this belongs to R1. So sorry, R2. It belongs to R2. Suppose the first point, then this first point belongs to R2. So I will put it here 1, and other membership is 0. Here this second point is belonging to R3. So the membership of this is 1 here, and others are 0, and so on. So we have trained this system that this point belongs to this region, this point belongs to this region. Based on this, it will neural network, what is the neural network is doing? Is processing this information, and then you give some another point, it will suggest you that in which region it will be. So the new point we have given. This is the new output, single data point we have given. And now I'm asking from this system that what is that? Then it has given that the membership value of it is to be in the region 1 is 0.1, 0.8 and 0.1. Of course, it is high. It means there is a very high chance that this point is in the region 0.8. So, you know, sometime when I write A, then sometime it can, if I write like this, this system can recognize it as V, and sometime it can recognize some other letter. You know, the membership value that this is going to be the V, this system is recognizing. I gave you the live example. That look, let us see. This is R. It is N. You know, membership value is changing sometime. You know, minor change, the membership value is changing. V. This time it is V. And let us see. What is this? V. अच्छा, मुझे लग रहा है वो तुरंत लर्न कर रहा है कि ये बार-बार V लिख रहा है, इसको V बता दो. Right? So you understand that this is the way how the neural network is helping us to determine the membership values. Is it okay or not? This is clear. Means you are given some data in advance. For membership, neural network based membership value detection, you require some neural network, some data in advance. You require some data in advance. So for this data, with these data, you have trained the system and then you are asking from the system that where it will belong, and it will give you the membership values. It is giving you the membership values. Dorji, is it clear? Dekho, this is a very,
Yes, sir.
very typical mathematics. It's a but different type of mathematics. You may not have studied it earlier, and you may not. But let me tell you, this is the requirement of the time. Forget those days when the real analysis theorem, functional analysis theorems, those question answer will help you. Abhi to, you have to be expert in the recent technologies where the mathematics is being applied. Otherwise, you will be out. We have to make our value. So, of course, this machine learning technologies, we must be aware. Otherwise, nobody is going to respect us. At least in university. In academics, if you want to become a university professor, of course, let me tell you the membership value that you will get a job in industry, the value that you will get job in academics. If you know the machine learning is highest, if you know the machine learning is super highest. So super highest and the highest. If you know the machine learning, whatever you are doing, if you know the machine learning, if you know these soft computing algorithms, your chances will be very high, let me tell you. Because everybody is using this. The senior professors, I'm not criticizing the pure mathematics. Remember, please don't take that in that way. I'm not, because that has their application. But what is the requirement of the time? The flow of the time is, you see the many senior professors I've seen. They have worked 30 years. They may have worked for 30 years or so. They may not have enough citations. Then just 2 years passed out. PhD students who is working in mathematics student, he's a mathematician who have worked for 30 years, senior professor, very active professor. Citations of this 2-year boy may be larger than that. See, do you know the Shubham? Shubham citations are much larger than many senior professors working in the pure mathematics. And he's just a 1.5 year, 1 year in fact, 1 year pass out student. My citations are highest in the university. Forget about the department. It is highest in the university. Even I'm not the senior most in the department or in the university. In fact, I'm among the juniors, the junior most, right? But still the citations are high. It is not because my is great. It is because the soft computing is being applied everywhere. Everybody is considering my research papers. The mechanical engineer, the civil engineer, the mathematicians, the computer science, the biotechnologist, the biology person, medical person, robotics, everywhere they are citing research papers. While the research papers from mathematics are being applied by mathematicians only. And therefore the citations are. And let me tell you, these days, I don't know how long it will go, but these days the citations is the big business. Means your capabilities are determined by the scientists with the citations. That how many people are reading your research paper. You are writing research, you are a great researcher, but whether people are using your research or not. And it is determined, how it is determined by the citations. So the people are converting my research into the technology, into the hardware. Very recently, somebody has designed one corrugated horn antenna, this mobile antenna design based on my one algorithm, spider monkey optimization. I think Situ Moiddin, you people must be aware of that. You should read that paper. Somebody in US made that antenna, right? So, but the real analysis theorem, algebra theorem may not be converted so easily. Those theorems and those rules I'm using we are using when we are developing these kind of technologies or fuzzy. But what the hardware people are using or what the engineers are using is the technology that we are developing. Right. So I'm in favor that whatever I'm teaching, you do not restrict yourself to those lectures only. What I strongly recommend, you go through this book deeply, Zimmerman that I'm going to share with you deeply, and most importantly, the other lectures on internet, YouTube lectures, NPTEL lectures, Coursera lectures. There are many on soft computing, machine learning lectures. And instead of watching the movies, whenever you feel bored, just on your laptop or mobile, wherever you want, you just switch on that video lecture and just keep on. Even if 50% is understood, it is okay. What wrong with it, right? Try to make yourself sellable in the industry. You are in the second year, you will pass out. If you will to somewhere in the industry, will tell you that I know the fuzzy logic, I know the neural network, I know the swarm intelligence, I know the evolutionary computation, I know the soft computing, machine learning. You will be immediately hired even for the industry, R&D, IBM people, IBM. These people are taking you. But if you will say that I know the algebra, I know this, they may hire you for the algebra on analysis basis also, but the membership value is less, the chances are less. And here the chances will increase. If you will say that I know algebra and soft computing both, algebra also I know, then your chances are very high. Of course, don't leave that analysis, that those are the core subjects. You must be aware of those subjects also. Okay, so the genetic algorithm, I will come back when I will tell you after this fuzzy logic, I will teach you genetic algorithm. Then I will tell you about the genetic algorithm. Inductive reasoning, you may leave, or just based on the induction. Actually, based on the induction, it is we are creating the membership values. Okay, now these are the examples here. What I recommend strongly that you do the practice of all these solved questions. Solved questions are there in this book. Unsolved questions are also there. And I strongly recommend that you do the practice of all these questions. For example, these are the questions here. Exercise problems. I strongly recommend that you do the practice of all these questions. Suppose, look, this fuzzy member, very full, medium, small, very small, right? So it is like this. How many? Five are there. So this is here the membership function will be of five. Five categories are there. Instead of low, medium, and high, there are 5 categories here. So similarly, you can solve all other examples. Next time, I will come with the defuzzification. In the defuzzification, again, there are certain methods. For example, the lambda cut method is there. This lambda cut method is there. The max membership centroid. This centroid method is the one most important actually. This is the most useful method, popular method, centroid method, lambda cut method. I'll discuss these methods. And then at last, we will come at this fuzzy inference system. In fact, I forgot to share with you. I'll share these slides book with you, so you can go ahead. In advance, you can study, and next time you come to class, in advance you can come. So this fuzzy rule-based system or fuzzy inference system, it is the same thing. So this is the last topic that we will study, and this is the major topic actually. There are mainly 2 methods in this, Mamdani and Sugeno. Mamdani and Sugeno are the 2 methods. It is somewhere here. So those 2 methods we will study and will implement on MATLAB also. Like this. I will make the MATLAB toolbox like this, right? I will show you that. And I hope everybody of you have the MATLAB in your laptops. If you have, it is very good. If not a big problem. But if you can install, it is very good. You people are mathematics students. MATLAB is the one very basic tool for mathematics students. Okay. See you next time.
Excuse me, sir.
Now, Monday, who is speaking?
Sir, it's me. I have a question.
Yeah, Tarun, tell me.
Are there any comparative advantages or disadvantages of one fuzzification method over the other?
What kind of fuzzification or defuzzification?
what I'm saying is this specification method is good, and over
Okay.
this
So
method.
yes, Tarun, actually deterministically, nobody can say that this fudgification method is good. Actually, in all the soft computing algorithm, this is a big challenge that which method is the better one. So the situation based, according to the problem, which method is suitable to which kind of problem. The first condition we will take them, and of course, usually we avoid the intuition based methods. Intuition based methods we use only when the problem is very simple, very straightforward. So, but other methods are according to the properties of the problem, that what kind of problem you are using, and there is no thumb rule that this method is better than the other. Depends, and also the output will be different. If you are using different method, the output will be different, and nothing is wrong. Nothing is wrong. You know, the one AC, suppose the Samsung AC is giving you said the 30, and Samsung AC is giving you 29, 31. And there is another AC which is giving 28.5 to 31.5. He's using some other fuzzy inference system. He's using some other fuzzy inference system. So comparing those is actually change. Because for me, if I said 30, then I even would prefer that if the temperature varies from 28 to 32 and my compressor is not starting, it's okay. I would prefer that. It will save my energy, right? And you may be interested as close as to 30. Whatever the cost, I don't mind. Whatever is the price for the energy, I don't mind. Let energy go, but my temperature, room temperature should be maintained as close as to. And in my opinion, I may say that, okay, energy is for the best. So it depends. What are your preferences? What is the problem? So actually in soft computing, there is no way we can that this method or this algorithm is better than the other. These PhD students are much aware of this concept that no free lunch theorem. Kyun, Situ? And this is always true. है ना, दिस इज ऑलवेज ट्रू. इन लोगों को बताऊंगा, नो फ्री लंच थ्योरम बताऊंगा बाद में, कभी बताते हैं. ठीक है, चलो, सी यू.